In today's lesson, we are going to talk about variables in C programming. Think of a glass of water. If you want to drink some water, then you put water inside glass and drink it. You can think of a variable as a glass of water. As a glass can store water in it, similarly, variables can store some value in it. After storing the value, you are free to use this value in your program. In reality, variables are simply names that points to some memory location. Thanks to the inventor of C language, who makes it easy for us to store values in memory by simply using the name of our choice. You don't need to worry about at which location of memory your value is stored. Your task is to just provide the name, and internally it will point to some memory location. But there is one thing that we need to be sure about. You must have to declare variables before using it in your program. Declaration simply means announcing the properties of the variable to the compiler. Here, by saying properties, we mean that what will be the size of the variable and what will be the name of the variable. Don't worry, it is not a very difficult job to do. You will see in a moment how easy it is to declare a variable. There is one more term called definition of a variable, which means allocating memory to a variable. Most of the time, declaration and definition will be done at the same time. But this is not always the case. It depends on the modifiers you had mentioned with the variables. We will talk about modifiers later, and then we will also explain how declaration and definition is different for different modifiers. Let me give you an example of how to declare a variable. Here the name of a variable is var, and it has integer data type. Data type simply means how much space a variable is going to occupy in a memory. Therefore, by writing int var, you are declaring a variable. Along with that, you are requesting the compiler to allocate memory for this variable. Please note down one thing. Here after int var, we had put a semicolon over here. This is very important because this is how your compiler separates one statement from the other. So don't forget to add semicolon at the end of the variable. Now, memory location depends upon the type you use. Here, because in our example, we are using integer data type, therefore, it may take either 2 bytes of memory or maybe 4 bytes of memory. It purely depends on the system you are working on. Again, you don't have to worry about how much space is allocated to your variable. You only have to concentrate on the declaration and definition of the variable. If you assign some value to a variable at the time of declaration itself, then this thing is called initialization. This is how you will do initialization. Note, initialization of a variable doesn't mean that you cannot change the value of a variable afterwards in your code. If you want the value to be changed somewhere, then you can do that. This clearly captures the meaning of a variable. Variable in its pronunciation has word vary, something that can vary over time. On the other hand, constant is just opposite. Once defined will never change. Let's see how we can change the value of a variable after initialization. Let me write down the code here. I'm writing #include stdio.h, that is our header file, because we have to print some output. Then I'm declaring a main function. Inside this main function, I'm first declaring a variable named var. Suppose I'm initializing it first to 3, and afterwards I changed this value to 4. You can observe that I had not written int var again. In this statement, I had not written int var again when I'm assigning value to it, because memory is allocated to the variable once, and defining it once again means you want to allocate memory again for the same name, and this is illegal. Note, each variable must be defined only once but it can be used multiple times with different assignments in your program. But there is one exception as well. When we study scope rules later, you will understand that same variable name can be defined in different blocks of code. You will slowly understand what does it mean. For now, it is enough to know that inside this main function, you cannot define multiple variables with the same name. Then suppose we write printf with d and we print the value of the variable. I will explain you more about that what this %d means. For now, I can only tell you that this will print the contents of the whatever is there inside this variable var. You have to put at the end returns 0. Let me save this and build and run the code. You can see the output here, which is 4. Previously, I had initialized the value to 3. Then I changed it to 4 and print it. And as expected, my output is equals to 4 without any errors. You can also assign variable to a variable instead of this constant value 3 or 4. Int var1 is equals to 3. Suppose my new variable is var1, and suppose I declare another variable var2. Then var2, suppose I initialized, or you can say I assigned value to it with the value of var1. Here you can see I'm assigning value of 3 actually, because writing the name of the variable means that I'm assigning its constant value, and I'm assigning it to variable 2. Let's print it using printf. Let's debug. As expected, the output turns out to be 3. You can also assign same value to different variables in single line. As you can see, I declared and defined variables in the same line using the same data type. All these variables are of integer type. Instead of defining and declaring in different lines, it is better to write them down in a single line. Suppose I assign them value is equal to 4, all at the same line, and then I print. Let's build and run. And as expected, we get value 444 because we had printed 3 times the 3 different variables var1, var2, var3. As because all of them has been assigned with the same value 4, that is why we are getting 3 values 4 in the output. Okay friends, this is it for now. See you in the next lecture. Bye.